your official UEFI person who knows everything. That is Peter Jones, who will correct me every time I get anything wrong. But I come into contact with UEFI during testing. We need to make sure it works when we test Fedora. So I had to learn a bit about how it works, and it seems like a topic that people would like to know at least enough about to be able to deal with, and this talk is my attempt to explain UEFI on a very high level, just so you know how to boot your system properly, which is kind of what you want to do with it. Yeah, we're past 10, so I guess we'll get started. So the structure of the talk, I'm going to sort of do a brief overview of what UEFI is, and a very high-level conceptual explanation of how booting with UEFI, which is what we really care about, works, and then practical tips, especially in a Fedora context, just how do I deal with this crap on my system. I want to get into the OS and not care about it anymore. What is UEFI? It is an industry-defined system firmware standard for computers. Firmware, at a very simple level, is what happens between when you press the power switch and when you see your bootloader menu come up. You don't really need to know anything more about it than that. It's just the bits that happen right there. So what we had before UEFI was BIOS. Sometimes people refer to UEFI firmware as BIOSes, which is wrong and kind of annoys us because BIOS is the thing that we had before UEFI. BIOS was never actually a standard. It's not really written down anywhere. You can't go and look at the BIOS standard. The standard for BIOS is what the IBM PC did back in the early 80s and what Windows expects BIOSes to do. That's your sort of ad hoc BIOS standard. It's required by Microsoft for systems that are installed with Windows 8 or later are required to have a UEFI firmware, and all Intel Macs have used EFI or UEFI firmwares. So if you buy a new computer now, it's pretty much going to come with a UEFI firmware. If you bought one in the last 2 or 3 years, it probably has a UEFI firmware, even if you're not native booting it. So you're going to come into contact with it. How does UEFI booting work at a very high conceptual level? So it kind of helps to talk a little bit about how it worked in BIOS, because you're probably familiar with the boot sequence on a BIOS system. That's what you've probably been dealing with for years. BIOS understands disks, knows what disk is, and the boot sector, which to a very simple level is the first sector of the disk. All BIOS knows how to do is execute whatever it finds in the first sector of a given disk. And it does this in an incredibly antiquated way, because the standard is what BIOS did in the 1980s or 1970s, whatever it was. It doesn't understand partitions, it doesn't understand file systems, it doesn't understand executables, it doesn't understand protected mode. So it's this firmware level of BIOS booting. The thing that people sort of like about it when they don't think about things too much is it's very simple. All you have to decide is which disk do I want to boot. So that seems nice, but it has some pretty nasty consequences, because in the modern times we don't just want to boot some very, very 1980s code from a single disk. So there's a whole lot of complexity to the BIOS boot process which is kind of hidden from you and which you don't encounter at the firmware level. And I sort of summarized various bits of it here that we don't need to go into a lot of detail on, but there's just a lot of mess that you don't necessarily know about, and you don't have problems with it very often because we've had 20 years to clean it up and hide it from you as far as we possibly can. But people like Peter know about all of this stuff in a lot of detail and hate it, hate it, hate it, hate it. So to go through it very briefly, the embedding area, there's a sort of secret hidden area of any BIOS type disk, MBR disk, between the boot sector and the partition table and the first partition, and that is where your actual bootloader lives. And this is just sort of blank space on the disk that isn't really accounted for in any formal way at all. We just dump bootloader code there and have horrible hacks to run it out from the first sector, and it's this horrible system. Chain loading, because The firmware has no concept of different operating systems and multi-boot. We have to implement all of that in the bootloader layer, and there's lots and lots of different ways of doing it, and they're all hideous. Who the hell owns the boot process anyway? The firmware kind of owns it because it initiates it, but because the firmware is very, very simple, we have to have a bootloader, but there's no interface to the bootloader exactly. You have to control the bootloader from the operating system layer if you want to configure it, and so you have this nexus of, is the firmware in charge of this, is the bootloader, where do I configure it? Is this operating system owning the bootloader? Is this operating system owning the bootloader? Are they all competing for control of the bootloader? It's horrible. No configuration from the OS layer, and as I said, lots and lots of mess involved in making this work. It's kind of like the duck. You see this duck of operating systems gliding along smoothly on the surface, and then underneath the feet are running furiously trying to make sure it doesn't all explode in horrible pieces. So UEFI adds it sort of adds a lot of complexity at the firmware level, if you look at it in that way, and this makes people get hung up on it, and they look at it and they think, man, this is really complicated. I didn't have to think about any of this when I went into my firmware UI with BIOS. All I did was pick a disk. And they're like, why does UEFI have to be so complicated? It's adding firmware it's adding complexity at the firmware layer, but all that complexity exists with BIOS. It's just the stuff we've talked about that's being hidden from you in various really grotty ways. And what's happening with UEFI really is a lot of that gets moved into the firmware. So now you kind of, maybe, if you want to understand what's going on at the firmware layer, have to know about this, but it's not new complexity. It was all there before. So UEFI understands a lot more than BIOS. It understands partition tables, it understands file systems, and it understands executables. And it does a lot of other stuff, but as far as boot is concerned, this is what we care about. So there is an EFI executable format, which you don't need to know any details about. You just need to know that EFI can run executables, and knows what an executable is. There's a partition table format that's kind of associated with UEFI called GPT. It's not MBR, and again, we don't need any details about it. Really, we just need to know that it exists, and it's a thing that all UEFI firmwares are required to understand. There's a UEFI standard file system, which is basically FAT, and there's some, it's a frozen version of FAT. So if FAT gets upgraded in the future, UEFI FAT doesn't change, but it's basically FAT. And again, the point is that UEFI understands this file system. Any UEFI firmware has to be able to read this particular type of file system. And there is a component of any UEFI firmware called the EFI boot manager, which is a subsystem for accessing and executing UEFI bootloaders. The fallback path we'll get to in more detail later, but it's the way UEFI implements. There's a disk here, and I don't know anything about it. I haven't been fed any detailed configuration for how to boot from this disk, but I want to boot from this disk. How do I do it? The fallback path is the way UEFI does that. And there's something called the BIOS compatibility mode, or CSM, which again, I'll talk in more detail later. Almost all production UEFI firmwares have CSMs, I think, Peter?
Not anymore.
Not anymore? Okay.
Stopped starting like October last year, stopped shipping it.
Oh, really? Okay.
Because Microsoft requires you at least disable it.
Okay. Okay, so some firmwares don't have this, and it's kind of nice if it doesn't, but a lot of UEFI firmwares have it. What the CSM does is it allows the UEFI firmware to imitate BIOS. So if you boot a UEFI system, this is a selection that's made at boot time in some way, and if you boot with BIOS compatibility with the CSM, once the firmware stage is done, you basically have a BIOS system. So far as every layer below the firmware is concerned, or above the firmware, however you look at it, is concerned, there's now a BIOS. This is not a UEFI system anymore. The operating system has no idea there's a UEFI firmware in the system. It's just a BIOS system as far as the OS is concerned. And that's a boot time choice, and you cannot switch modes once you boot it. But at the next boot, you can pick the other mode. And again, we'll talk about that in more detail later. So what does UEFI do with all this new understanding? A very approximate way to look at it is that if you look at what Grub does on the BIOS system, you get a bootloader with a list of things you can boot. And what UEFI does is it does a lot of that inside the firmware. So there is kind of, with the UEFI system, assuming you're booting in native UEFI mode, not BIOS compatibility mode, there is, well, again, there's a boot menu in the firmware. And it has internally a representation of list of things that could possibly be booted. Because it understands executables and file systems and partitions, it can say, okay, one entry on my list is this bootloader on this file system on this partition, and it can do all these things that grub does. So things you can have in the UEFI firmware boot menu are sort of a native boot entry. A typical one would be, hey, on this partition, on this disk, run this bootloader, which is a UEFI formatted executable. So when you do a UEFI install Fedora, you get a Fedora entry which says, run the executable blah 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 from this partition here, and that is the grub, the UEFI version of grub, and that then takes over and boots the rest of Fedora. You can have an entry which is basically a disk entry, which says boot from this disk, and that uses the fallback path thing we were talking about. I think I'll explain how that works in a bit. But yeah, and you can have, so BIOS compatibility is actually implemented. It's an entry in UEFI's internal boot menu. So there can be a menu item which says boot this disk in BIOS compatibility mode, and when that entry in the boot menu gets selected, that's when you get a BIOS compatibility boot. So if you can see a representation of your firmware's boot menu, you might see any of these entries in it. And there are complicated advanced ones that I'm not going to cover because you don't really need to know it. This is how things look to the firmware internally, and there are tools you can run to see the current boot menu from your firmware, but you don't necessarily see it in the firmware interface. One of the limitations of the UEFI standard is it specifies almost nothing about how it should be represented to the user. So when you hit delete or F2 or F12 or whatever at boot time and get into your firmware interface, it could look like anything. There are lots and lots of different ways of representing this to the user, and some expose it very directly and they just say, like, look, this is the boot menu, you can add entries to it, you can pick one to boot. Some obfuscate it really, really heavily and represent it in really terrible ways, so it's not clear at all that this is what's going on internally. So when you look in your firmware, you may not see exactly this, but it is there in the background. It's required to be there by the standard. So the firmware UI may let you choose an entry to boot or just say do something else entirely that's not in the menu, in which case the firmware will add it to the menu temporarily and then run it. And you can, using the tool I was mentioning, UEFI Boot Manager or another one for Windows, at runtime in your operating system, as long as you booted UEFI native, not BIOS compatibility, you can say, you can edit the menu itself, you can add new entries to it, you can delete entries from it, and you can say, on the next boot, boot this entry. And you can say, put this entry at the top of the list for the future permanently. You can do things like that from the operating system layer, which you can't do with BIOS. Well, kind of, but not at the firmware level, you can. Yeah. Oh yeah, so I wanted to mention a few consequences of that. So it kind of what I was saying earlier, but this seems like more complexity in the firmware, but the trade-off is that we don't need this complexity at the other layers anymore. So for instance, I mentioned the embedding area briefly, which is this horrible place where we keep your actual bootloader with BIOS. We don't have that with UEFI because now the UEFI standard gives us the same way, and your bootloader is just a file on a file system that you can mount from the OS layer and write or delete or modify or whatever. It makes things so much easier and better for OS installers because we don't have to do this crazy stuff through grub2 install to put the bootloader in the embedding area. We just dump a file in a file system, and that's your bootloader. So it's moving complexity to a different layer and actually making things better, but unfamiliar. And yeah, in theory with this UEFI system, it solves the problem that I mentioned briefly of how do we do multi-boot, again, in theory I'm saying, and which operating system is in control of the bootloader and blah, 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 because it's all in the firmware. There's no confusion or competition about who's controlling it. In practice, it doesn't do that so well because implementations of UEFI don't handle the boot menu particularly well and don't represent it very well, so we found that when we were first implementing UEFI in Fedora, we thought, hey, we can just make it an entry on the internal boot menu, and we're sure that systems will present that quite easily to the user, and they'll be able to pick to boot Fedora or Windows or SUSE from their firmware boot menu, and they'll all be fine. We won't have to ship, grub with Windows entries anymore. And that's not what happened. So in practice, this kind of sucks, because what's probably going to happen in the future is we're going to have a more complex firmware, and we're still going to have bootloader, like a grub menu with Windows and Fedora and SUSE and whatever else you have installed, because we can't rely on the firmware to handle it very well for the user, so we're just going to have to put it in the bootloader menu, which kind of stinks, but at least in theory, the standard tried to fix it. Okay, so moving on to practicalities, which is, I hope I've given you enough of the theoretical underpinning that we can now talk about how do you actually deal with this as a user when you're installing Fedora. The first thing you have to establish is my system a UEFI system? Do I have a UEFI firmware? Which can be slightly more complicated than you'd think, but there are a few pointers. Simply, did it come with Windows 8 pre-installed? Yes, you have a UEFI firmware. Did it come with Windows XP or earlier? No, you do not. Windows versions 7 and Vista are more complicated. They could have a UEFI firmware or they could not, so you can't really rely on that. Does it mention UEFI anywhere during boot or in the firmware interface? When you press F2 or delete or blah blah blah, you may see the words UEFI somewhere, and if you see that, you pretty much got a UEFI firmware. It may be on the big pretty splash screen you see. Just look for mention of the UEFI. You could, I know it's very, very web 0.1, but you could open the manual, which probably came with your system or your motherboard, and see if it says anything about UEFI. Is the firmware interface at all graphical, or can you move your mouse around in it? If so, it is a UEFI firmware, because BIOS can't do that shit. If all else fails, ask for help. There are enough people in the Fedora community now who vaguely understand this stuff and can probably figure out for you. They can do all this stuff looking online and figuring it out one way or another. But you kind of need to know, if your firmware is not UEFI, then you can ignore this whole thing, you don't have a problem anymore. If it is, continue with the presentation. Did I miss anything there?
The first line only applies to client machines.
Yes, that's true, but I'm figuring out more or less what we're dealing with here. We're kind of talking about desktops here. If you're doing big installations of weird server systems and blah, 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 let me know. So the simplest case is single booting. You just want to boot one operating system on your computer, and you don't care about existing partitions or data or anything like that. You're doing a clean install of one OS. It's pretty hard to get this wrong, especially with Fedora these days. You can do a UEFI native install, you can do a BIOS native install. I haven't mentioned secure boot at all yet, I will later, but it doesn't matter whether it's on or off as long as you're running Fedora or another secure boot capable distribution. The only thing you may have trouble with is writing install media that you can boot properly. So, if that's a problem you have, then pay attention and read the slide deck later. But you can, if you just want to do this, you can kind of just get the install booted any way you can and go ahead and run the install, and there's a fairly high chance that when you reboot it'll work. Don't worry about UEFI too much if that's all you want to do. Multibooting. The single takeaway, there are two takeaways that I want you to have from this talk. One is the difference between UEFI and secure boot, which we'll talk about later. The other one is, if you're trying to do a multi-boot install with UEFI, install your new operating system in the same mode as your current one. This is the #1 thing that people get wrong. When I say mode, I'm talking about native UEFI versus BIOS compatibility. If you have a native UEFI installed with Windows and you try to do a BIOS install with Fedora, you're going to get in all kinds of pain. We're going to go into details about how you actually ensure that now, and that's one of the most important things, but this is the concept you have to keep in mind. Know which mode your current OS is in, and install your new OS in the same mode. So again, you need to know how to do this, right? So you need to know which mode your current installation is in. There are some details. There's a wiki page that I've written in the wiki. If you just go to the Fedora wiki and search for UEFI, you'll find it. It's probably the first result, and I go into more detail about that there. But I can give the sort of overview in the talk. Again, if you have Windows 8, client Windows 8, it's UEFI native. You don't really need to go beyond that, unless you did something very, very strange. It's a UEFI native install, so you want to do a UEFI native install of Fedora. If you have Vista pre-SP1, it is definitely a BIOS native installation. Yeah.
So why is that? Why you cannot do multiple BIOS and UEFI?
So you just can't do them on the same disk because of the way the bootloader works, the way the main thing is the partition table. So what we say as a handy simplification is that UEFI needs you to have a disk with a GPT partition table. BIOS needs you to have a disk with MDR. Neither of those things is absolutely strictly true, but it's a good enough approximation that you can go with it as a rule of thumb. And that's the main reason you should never cross the streams.
Specifically, if you got a machine that was shipped with UEFI, then it's got a GPT partition table, and it's probably aligned such that we don't really have an embedding area there.
Right. You can't. And going the other way, if you have a BIOS installed operating system, you almost certainly have an MDR partition table. And now we looked this up, and theoretically, the UEFI spec does not absolutely state that you have to have a GPT partition table.
Yeah.
But everyone kind of assumes that you're going to have one, and we've actually made it so Fedora just will not do a UEFI native install through an MDR disk because we figured trying to support it was just going to lead to more pain.
And nobody's noticed.
Yeah. Well, nobody noticed directly. We had bugs, which we didn't quite figure out for a long time what was going wrong, and then we realized, they're trying to do a UEFI native install through a BIOS partition table, and this is the problem. So yeah, it's one of those things where at a useful level, just don't cross the streams, don't do it. If you really, really know what you're doing, you can try and do it, and you will suffer horrible pain. But just don't. So yeah, Vista pre-SP1 is always going to be a BIOS native install. Don't try and do a UEFI native install of Fedora to such a system. Do a BIOS native install of Fedora. There are, like I say, more details on the wiki page, but if you have Windows installed and you're not sure, possibly the best thing to do is run the Windows Disk Management tool, which you can find information about on the wiki page or on your favorite search engine, and look for an EFI system partition on the disk Windows is installed on. If there's an EFI system partition, it's 99.9999% a UEFI native installation. If there isn't, it almost certainly isn't a UEFI native installation. If you have a Linux installed system, a handy way to do it is just run EFI Boot Manager. You don't have it installed, install it and then run it. Your distro will almost certainly have it packaged. If it returns, so this is the tool that tells you what's currently in your firmware's boot menu, and if it returns a boot menu, then you've got a UEFI native install. If it returns an error, you've probably got a BIOS native install. So make sure you know how your current OS is installed. If you don't know, don't guess. Find out, and if you're having trouble finding out, ask someone for help, because this is where people get in the most trouble. Especially with Fedora, and I think with most Linux distributions, if you boot the installer in UEFI native mode, you will get a UEFI native install of Fedora. If you boot the installer in BIOS compatibility mode, you will get a BIOS compatibility mode install of Fedora. People ask, well, hey, can you just give me an option so I can boot UEFI native and do a BIOS install? And we say, no, just no. We don't want to do that. It's a really stupid thing to do. Please don't. There was a horrible hack you could do with older releases where you could boot UEFI native and pass a kernel parameter, and then the installer would think you were booting BIOS native and do a BIOS install, and that stopped working, and people ask us to fix it, and we say, no, this was a horrible bug, and we fixed the bug. You don't want to do that. Don't do that. So, yeah, don't do that. Just get the right mode for boot, and we're going to go into details about how to do that. In fact, we're going to go into details about how to do that right now. So if you pretty much any install media you write via anything is going to be BIOS bootable. You'd have to work really hard to write one which wouldn't boot in BIOS mode. Writing install media which will boot in UEFI native mode is the thing that usually trips people up. So if you need to do a UEFI native install, you need to write media that are going to boot in UEFI mode. One thing, if you're writing optical media, and you're using a tool which works properly at all, so you get something that's bootable, it'll be UEFI bootable. You write your ISO image to your optical disk, that's going to be UEFI bootable as long as there's nothing weird about your firmware. The trickier case is USB sticks, which obviously people like to write from a lot. We've been trying to encourage people pretty heavily lately to use DD to write USB sticks, because it's the simplest method, in a sense, for users, because it's either you did it right or you didn't do it right, and it's the one that we have the most control over when building images to make sure that everything's right. So the best thing to do is use DD or a DD-style tool for Windows or OS X. Again, there's a wiki page about writing USB media, which I try to keep more or less up to date and accurate. and it's like how to write USB or something like that in the wiki. I have a resources page at the end of the talk that links to all these things. And that goes into quite a lot of detail about how you do a DD type write with Windows or OS X. That's the best thing to do. If you really have to use another tool, if you're going to use live CD ISO to disk, pass those 3 parameters. This is LibreOffice, but those are double dashes. So it's dash dash EFI, dash dash format, dash dash reset, single dash NVR. As long as you pass those 3, it'll destroy your stick. It's a destructive write, so don't do it if you need to preserve data. Use a stick you don't need to preserve data on, but that almost certainly will get you something UEFI bootable. If you use Live USB Creator, it might work. It depends on the current contents of the stick and possibly how you call Live USB Creator. It can write UEFI capable media, but it's pretty easy to get it wrong. Don't use UNetBootin. Please, please don't use UNetBootin or similar tools. Generic USB writers, they don't get it right. They don't write UEFI bootable media, they don't write Mac bootable media, it's just don't use them. So really, really try to use DD. And yeah, I'll give that reference in a minute. So the next thing, assuming you needed to do a UEFI native install, well, actually either way, once you've got boot media that you know can boot in the mode you need to actually tell the firmware which mode you want to boot in, because, as I said, it's a boot time option. People ask us, well, can't we sort of configure this at the installer level? And no, we can't. It has to be done at boot time, and it has to be done at the firmware layer. As I said, UEFI standard does not prescribe almost anything about how the user interface should look, which gives us a problem with documentation because we don't know what your firmware is going to look like. So all I can do in this case is give you some sort of pointers. I should have talked about secure boot, but I haven't yet. But again, as far as secure boot goes, I'll wedge a bit in later where I talk about when you might want it, when you might not, but it's usually a toggle, and the thing you need to know at this point is that secure boot is not UEFI. If you turn secure boot off, you have not turned off UEFI. You have not gone into BIOS mode. All you've done is turn off secure boot, which is a sub-feature of UEFI. You may well still be doing it on UEFI boot, just with secure boot turned off. So the thing that you actually are looking for here is whether you're doing a native UEFI boot or BIOS compatible boot. And I've seen this represented in all sorts of ways. There may be just a simple toggle, which toggles between native UEFI mode and BIOS compatibility mode. You may be able to, you may have a direct representation of the boot menu, and say you plug in a USB stick, which is both BIOS and UEFI bootable, your firmware may show 2 options for booting that stick, and one of them is UEFI and one of them is NVR or BIOS, so just doesn't say anything, just says the stick's name, which is a nasty one because... Yeah, true. Which is a nasty one because that's what my firmware does, and I had the trouble of writing a UEFI native medium the first time I tried to install UEFI, and my firmware just had an entry for the stick. And I didn't know how it showed a UEFI boot until I succeeded in writing the media properly, and then I saw it had 2 entries, one of which said UEFI. But in the failure case, you couldn't tell what was going wrong. So it's a little tricky, but you have to be aware of what you're trying to do, and sort of look around and just try to figure out how is my firmware representing this. Yeah, I may let you manipulate the boot menu and choose to boot external media directly. So what the firmware actually does at this point, it can be handy to know, is that all of this is an abstraction on top of the bootloader's, the firmware's internal representation of the boot menu. What it's actually going to do is possibly generate an entry in that boot menu on the fly, and then it'll boot an entry from that boot menu. That's ultimately what it's doing. It's just how it's showing that to you. So, maybe, as I said, this is a little tricky, so maybe you get your stick booted and you're still not totally sure how you booted it. So this is a handy thing to know. Before you do anything, before you run your installer, find out what mode you're in, and make sure you got it right. So in Fedora, drop to a terminal, which is Control F4 in all current versions of Fedora, and as I said, run EFI boot manager. And the other way you can do it is look in this directory. If it's populated, if there's lots of stuff in it, that means you got a UEFI native boot. Again, run EFI boot manager. If you see a boot menu, you booted in native UEFI mode. If that's not what you wanted, reboot now. If you get an error message, you boot it in BIOS native mode. If that's not what you want, reboot now, and just keep rebooting until you get it right. There's no penalty for failure, so make sure you get it right and check before you start the installer. There's a kind of hack, I shouldn't cover this. The no UEFI thing is the thing I mentioned about, that's the gross hack about how you do a UEFI native boot and get a BIOS installed, but don't do that, it's bad. In Fedora, we use a different bootloader for BIOS boots of images compared to UEFI boots of images. So if you know what you're doing, you can actually tell which mode you booted in just by looking at the bootloader, but it's much better. The first option is the one you should really use, because that's reliable and it's going to keep working. So yeah, make sure you got your mode right, and once you make sure you got your mode right, go ahead and run the install. As long as you got these things right, the Fedora installer is almost always going to do the right thing as long as you got these things right. So these are the things you have to do, and then once you hit the installer, if you're just trying to do a dual boot with Windows, you can just go ahead, as long as you do automatic partitioning, you can just go ahead and walk through the steps, and it'll do it right for you. If you're doing custom partitioning, for UEFI, you need a certain partition layout that you can create by hand if you know what you're doing, but it's probably best to click the little button in custom partitioning which says automatically create my partitions, and that will give you a /boot and a /boot EFI, and don't touch those, and then just do the rest of your layout however you want, modify the pre-filled ones, do your custom partitions, but just leave /boot and /boot EFI alone. Okay, so I had a thing, example UEFI firmwares, I had to open these up separately, so I didn't put them in the... I wanted to make this presentation redistributable, and these images are just crap I downloaded with, I have no idea what the copyright is, so I didn't embed them in the presentation, so you can get them separately. So these are just the sort of examples of firmwares you might say, I've got to go out of the presentation mode, haven't I? Well, this is one that you might see. This is from a gaming motherboard. Something P. Jones, I think it's P. Jones or possibly Matthew Garrett said to me yesterday. As a general rule of thumb, the more expensive and high-end your motherboard, the crappier its firmware is going to be. Because no manufacturers write their own firmwares. They contract it out to like one of 2 or 3 companies who specialize in writing firmwares. And these guys, they start out with a very simple firmware, which represents UEFI really fairly sanely. And then they offer, your ASUSes, your ASRoCs, your MSIs, the option to customize it and make it all shiny and graphical and have exciting rockets and stars. And then the firmware...
Fatality arithmetically speak.
And the motherboard manufacturers then don't really know what the hell they're doing and ask for all these crazy things. And the firmware authors say, okay, sure, we'll do whatever you ask, and you wind up with horrible firmware. So let me see, I took these screenshots a long time ago, so I'm going to have to remember how they work together. So this is one where the firmware is kind of showing you the menu, but it's a sort of merge of what you expected to see in BIOS, where you had boot option 1, 2, 3, and those would just be disks. But because this is a UEFI firmware, so you can see the second one down would be, if you pick that option, USB, Corsair, Voyager, whatever, that would give you the BIOS compatibility boot of that USB stick. If you pick the one which said UEFI, Corsair, Voyager, blah, 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 that one would give you the UEFI native boot for that USB stick. So this is one way that the firmware might possibly represent it. I don't think we have it here, no, not on the screen, but I think somewhere else in this firmware there's just a secure boot enable, disable toggle, which is how secure boot works on this one. Oh, that's what I did. UEFI presentation. This is another gaming motherboard from Asus, Republic of Gamers. I don't know. So that one's kind of similar. That one you can. So this one, these are just screenshots, so I can't tell you for sure exactly how this works. But I mean, this is a good example of a fairly weird one because it's got a CSN setting there, which is our BIOS compatibility mode. But then you can also see the boot option 2 with UEFI blah blah blah. So it's kind of exposing CSN in 2 different ways. So you can get some really weird stuff, and this is why I have the step of how you verify how you booted. Because you should really verify how you booted, because, I mean, once you negotiate this thing and you get system booted, it's not very obvious what you just did, right? So check what you did.
And you said people should never say UEFI BIOS. And
yeah, and that's what it says right up there. It's a losing battle I'm fighting with the UEFI BIOS thing, but I'm really trying.
I'm right there with you.
I think I've actually seen it in like something from Intel, and at that point I nearly just gave up and shot myself because I was like, oh god.
If you see that from Intel, we can probably call them and get them to take it down.
Oh really? I'd have to find out where it was, but it just made me facepalm so badly. I was like, oh god. I won't go through all of these, but I mean, here's another one. This just kind of illustrates you really can see pretty different interfaces, but all of these are just abstractions of the exact same thing. All these firmwares underneath have the little boot menu with all its options on it, and all this is doing is messing with that. So yeah, this has CSM support down there, and it has always and various other options, and you know, they're just, I don't even know what the security option is. It's kind of a mess. So yeah, you can see that you'll get different representations of it. That was, I think, all of my slides. Sorry?
Where is the menu here?
Yeah, it doesn't expose it at all. It might be on a different screen, or it might just be, I mean, I've seen ones which just don't give you an interface to the menu, and all you can basically do is enable or disable Secure Boot and enable or disable CSM. And if you enable it, then as long as there's something BIOS bootable connected to the system, you'll probably wind up with a BIOS boot. If you disable it, as long as there's something UEFI bootable connected, you'll probably get a UEFI boot. I mean, it gets really messy.
Some, but not all of the ones that don't show you a menu by default will
Yeah.
have like the press F12 for alternate boot options.
Right, yeah,
It's
it's horrible. So yeah, this is the biggest problem we have with explaining UEFI to people. Is like, I mean, standing up and doing it is horrible because there's just so many caveats running through my mind that I don't want to start spewing out. It's like, the best thing I can tell you is like verify. Don't trust, and verify is get it booted any way you can, and then make sure you know what mode you're in before you go and do anything else. And if you got it wrong, just reboot and try something different. And like I said, there's no penalty for failure. Just keep rebooting and trying and poking things until you get what you needed. You should probably, though, make a note of the before you start tweaking, make a note of the settings that boot your Windows install or whatever, so you can get back to it if you screw up. This is the point where I got to in my last version of this talk and said, hey, next time I do this, I should throw some more slides in there, and I totally didn't do it, so I'm going to have to wing it again. Secure Boot, we have not explained so far. Secure Boot is not UEFI. As I said, one of the #1 takeaways from this talk, they are not the same thing. UEFI existed for several years before Secure Boot. Secure Boot was then implemented as a sub-feature of UEFI, not really for any nefarious reason or any particularly weird reason, just because that was where it made sense to do it. I mean, Secure Boot as a concept kind of makes sense, and if you're going to do it in a world where UEFI exists, the sensible place to do it is as a sub-feature of UEFI. So that's why Secure Boot is a part of UEFI. There's nothing more to it than that. Secure Boot, what it actually is a system for doing cryptographic verification of the boot chain. So I'm assuming people more or less know what cryptographic verification is. It's just a way of making sure that what you booted, the code that ran between when you pressed the power button and when you got to your kernel, I guess, is what you wanted it to be and has not been compromised in any way. And it just uses public key signing. It's a way of saying, okay, we sign the firmware, we sign the bootloader, we sign the kernel, we sign kernel modules, we sign everything that's part of that chain with a particular key. And then when we boot, we make sure that all the bits of it are signed with that key, and if they're not, then we, throw up panic, don't boot. Very, very high level here, I know. So it's not an evil idea, it's not a particularly strange idea, and it's actually a useful idea in a lot of circumstances because the boot chain is a fairly large vulnerability if you don't have something like Secure Boot, and if you're actually in a situation where you're worried about a particular system being attacked in a quite targeted way, you should worry about boot chain, because if something gets in there, it's hard to detect it from the OS level, it's hard to fix it from the OS level, because the OS kind of, if you don't have Secure Boot, pretty much innately trusts your boot chain. So you're not going to see any indication that something has compromised your system. It's not going to be particularly easy to detect that it's happened. It's a pretty big hole that Secure Boot does plug in a reasonably sensible way. If you want to fix that problem, then something like Secure Boot is what you're going to come up with, a way of signing the boot chain to make sure that it is what it says it is, and it's trustable. It's really not as evil as you may have heard. It's not a Microsoft conspiracy exactly. It is a sensible thing to have. It is quite useful. Do you need it? The regular person doesn't lose a lot by having it turned on as long as it's working, but at the same time, I don't know if it's the #1 thing you need to worry about as a security problem. There aren't a lot of active general attacks against the boot chain in the world. There are some in the wild, but it's not your #1 security issue.
Isn't the signing key being controlled by Microsoft?
Yeah, I was going to get into that as part of the specifics. So yeah, we can deal with that now. How that whole thing happens, if you look at the Secure Boot specification, it says nothing, or what it says, it describes a mechanism for signing a boot chain. It doesn't say what the keys should be, it doesn't say who should control them, doesn't say anything of that. It's purely the method. Then the next thing up you look at, if you're looking at how Secure Boot works in the real world, is the Microsoft certification requirements, which you can find. There's links to them on my blog and various places. It's a public document. You can go and read it yourself and verify anything I'm saying about it. What the Microsoft certification requirements say is that any system shipped, any x86 system shipped with Windows 8 or Windows 8.1 or whatever must trust the Microsoft signing key, and it must allow you to disable Secure Boot, and it must allow you to register your own keys. That's more or less what it says.
And it has to be on by default.
Yes, it has to be on by default. It does not say that. It explicitly says that you must be able to disable it, and it explicitly says you must be able to register your own keys, which are very important freedoms that we should thank, is it you and Matthew Garrett for? Because these are things that we lobbied for, basically, as part of the Microsoft. But we said to Microsoft, this is something, if you don't want us to make a huge stink about Secure Boot, this is something you're going to have to do. It does not say that your firmware has to trust only the Microsoft key. It doesn't at all preclude people from shipping firmwares that trust the Microsoft key and some other key. So those are the underpinning specifications that you keep in mind. What's happened in the real world, the reason things are this way is that no one wanted to act. If you think about acting as someone who does Secure Boot signing, what you're doing is you're setting yourself up as an entity which asserts that boot chains are trustable, which is quite a difficult thing to do. I mean, people think about the technical side of it, they just want Secure Boot to work, but you have to think about what it really means, right? If you say, hey, I'm going to set up shop as someone who signs boot chains, you have to be able to verify that the boot chain you're signing is what it says it is. You have to, in theory, you have to read all the source code of everything you're signing and understand that it's actually not doing anything nefarious intentionally, it's not unintentionally exposing a big hole through which the boot chain can be compromised. You have to know you have a reasonable mechanism by which that code can be updated, which can't be exploited. I mean, it's a really tricky job to do. It's the same reason we don't have many cert authorities, and it's a very specific job to be someone who sells certificates, because there's a lot of... So, Red Hat didn't want to act as someone who signs Secure Boot keys for other people. The Linux Foundation didn't want to act as someone who signs Secure Boot. No one really wanted to do it. Microsoft was the only entity that stepped up and said, we're going to sign Secure Boot. We're going to do Secure Boot signing. Sorry?
We literally cannot.
Yeah, it's really expensive to do all this stuff, right? So, I mean, it wasn't some kind of huge conspiracy why Microsoft ended up as the entity which signs boot chains. It's kind of, no one else stepped up and said they were going to do it. There are some caveats to that. I said in theory, firmwares can trust multiple keys. In practice, there's a problem with driver signing, isn't there, I think? Where...
No, with multiple keys there's not.
No?
With,
okay.
If you ship a different key than theirs, you wind up with a problem where your NVIDIA card's option ROM is signed by a key that you don't have in your list.
Right.
But if you ship both, you're okay.
Right, okay, yeah. So I mean, in theory, the Linux Foundation could have set up shop, and then we could have gone to motherboard manufacturers and said, hey, sign, can you trust Microsoft's key and also trust the Linux Foundation's key, and we'll sign all the Linux distribution bootloaders, and the whole system was set up so that that could possibly have happened, but it just didn't. So, yeah.
Also, I think this promise to be able to
turn it off and to add your own keys is only limited to the FX.
Yes, you're right. I did add that caveat.
For UEFI ARM devices that
Yes.
are locked down.
The requirement, so as the question was, does this specific set of requirements from Microsoft apply only to x86? And yes, you're right, it does. The requirements for devices preloaded, for ARM devices preloaded with Windows are kind of the opposite. Secure Boot they have to ship and trust the Microsoft key. I'm not sure if it's only the Microsoft key, but Secure Boot has to be on and it cannot be turned off. The spec says there should be no option for the users to turn it off, and you cannot enroll your own keys.
You gotta stop pushing on that here.
Sorry?
Stop pushing on that.
Oh, I'm sorry. Ooh, yeah. I disconnected.
No, that's your laptop.
Oh, yeah. So, where was I? Yeah, so what they've done there, sorry, I'll come to your next question in a minute. What they've done there is basically, it's kind of evil, but then you have to look at it in context. And the context is when you buy an Android phone, or when you buy an Apple phone, or when you buy a Microsoft phone, you get a locked bootloader. And what they're doing with the requirements for preloaded Windows ARM devices is just the same thing that most Google manufacturers do, the same thing Apple does, the same thing anyone does, is they're locking the bootloader and they just happen to be using the UEFI requirements as a way to do that. And it's evil, but it's only as evil as what everyone else is doing. And the simple answer to that problem is, if you want an ARM device, don't buy a Windows ARM device. If you want to run a different operating system on an ARM processor, do not buy a Windows ARM device. Buy a different one. But it's the same thing. You wouldn't buy an iPhone to run Linux on. It's just the same thing as that. So, yeah, sorry, what was the other question?
Yeah, I had two sub-questions based on what I asked earlier. Does Fedora send its bootloader to Microsoft to sign?
I'm sorry?
Does Fedora send its bootloader to Microsoft
Yes.
to sign?
Yes, everyone. The only way.
And we verify that the thing we.
Oh, you're right. I'm sorry about that.
Repeat the question.
Oh, the question was, does Fedora send its boot chain to Microsoft to be signed? And the answer is yes. Anyone who wants to be bootable on Secure Boot out of the box with just have it work, so when you boot it on the system with Secure Boot enabled, it just boots, you have to send it to Microsoft to get signed. Because of the things I just said, Microsoft is the only public signing authority. That's the only option you have. It's the only game in town. So when you do that, you send it to Microsoft and you pay them a very nominal fee of $100, I think it is.
You do that to enroll in the program.
Right.
The $100 is to get a certificate that you can sign it with to prove that you're the guy who gets stuff with it.
Right. But yeah, I mean, you go through this process and then Microsoft does actually review it reasonably closely, but then they let Ubuntu's implementation through, which is horrible and filled with holes, so I guess they don't review it that closely. But
no, that was on purpose.
Oh, really? Oh, okay. See, these are all the fun little political details, but we're running out of time, so I should sort of skip over it a little bit. Very briefly, there's a way for distributions who aren't really big enough, don't have the time and resources to jump through the Microsoft hoops to get it done, which isn't horrible. And this is something Matthew Garrett did. So pretty much everyone who's doing Secure Boot with Linux is using something Matthew Garrett wrote called shim, which is sort of sits between grub EFI and the firmware. And you either sort of take shim and then sign it, the whole chain with your own key and send it through Microsoft, and you have something that will be completely out of the box. Or there's a generic version of shim which Garrett sent to Microsoft and got signed, which if you jump through, I've forgotten the details, I knew them before, but if you jump through one hoop as a user one time, you can say boot this operating system with this generic version of shim, and then from then on it'll work. Is the high level view of how it works. Yeah, so there's two ways of doing it. I just want to see if there's something. There's one thing I somehow managed to not cover during the talk, which in a way was on purpose. The EFI system partition is a concept you may run up against. And this is something, it's part of the fallback chain, which I was talking about, which is how UEFI actually boots from your devices. So when you plug in your USB stick and try to boot in UEFI native mode, there's no entry in the firmware's boot menu which tells it the specific bootloader it should run from the specific partition. So instead in UEFI there's a convention that if there's a bootloader in a particular place on a partition which has particular characteristics, and the firmware is told to boot from that disk, it will go and run that bootloader. And the EFI system partition, strictly speaking, is only needed for this fallback path. The EFI system partition is a partition with those particular characteristics that the firmware will look for when booting on the fallback path. The interesting thing that I didn't know before I put this talk together is that when you're booting a proper native entry which says go here and run this particular bootloader, it doesn't actually have to be on an EFI system partition. It just has to be on a partition that the firmware can read and that you can directly partition the firmware to. So in theory, you could put it on some random fat partition which is not an EFI system partition and write the correctly formatted bootloader entry for that, and your firmware will be able to boot it. In practice, all operating systems basically put their native bootloader on the EFI system partition because it's going to have to be there anyway, because you kind of want the fallback path to work if things blow up horribly. So if you're going to write an EFI system partition to the disk anyway, you may as well put your native bootloader there. But it's interesting to know, and it's kind of helpful, at least for me to know, that the reason the EFI system partition exists as a concept is for the fallback path, and it's just a way of codifying like how to boot from a disk you know nothing about other than the fact that it's a disk that the user wants to boot from. And that's what the EFI system partition really is. So I wanted to cover that briefly. So yeah, I did the same job I did last time and kind of didn't cover everything, but I hope that was useful for you all. And do we have any questions quickly, because it's 10 to 11? Any more? Yes?
Yeah, so...
You're Kevin, right?
Yes.
Yeah.
So but is UEFI not fundamentally... is secure boot, the so-called secure boot, which I call restricted boot, not fundamentally incompatible with free software? I mean, Shim works around it now with the possibility to enroll custom keys at
what I would say is,
in principle, the concept is incompatible with free software, that you can only boot things that have been signed by somebody.
the out-of-the-box implementation, if you want things, I would say the FSF, it's them who say restricted boot, right? I'm not wrong when they talk about restricted boot strictly. If you think of secure boot only as running through Microsoft and you think just of the Microsoft key, then yeah, I mean, it's kind of restrictive and it's not great, but secure boot as a mechanism I wouldn't say is incompatible with freedom, because you can enroll your own keys and it's possible to set up an entire boot chain that you have complete control over. It's just most people don't do that, but you can. Sorry, Peter had a take on that.
FSF takes the position that we do, and that is that if you have the ability to configure your own keys, then it is secure boot and that's okay. And if you do not have that ability, then it is restricted.
The problem with the ability is that it's quite complicated and difficult to do, but I believe Matthew is trying to work on tools to make it all much easier to sign your own boot chain. Oh, you're doing it? Okay, yeah. So we're trying to make it better to use the experience where you sign your own bootloader chain, but we don't have it yet.
And what security does it provide in practice if only, it secures at best up to the kernel. The Ubuntu implementation doesn't even secure the kernel, but most of it, ours does secure at least the kernel and the kernel.
Yeah, Peter has more details on that than I do.
But all the user space is still not signed.
Peter has more details. I mean, it's not meant to protect the entire system from soup to nuts, it's only meant to protect the boot chain. That's what it's for. So sorry, I wanted to answer the next question while we had time.
I'm sorry. So from what I read, Microsoft has the ability to blacklist keys using their Windows update.
That's, only if you're running Windows on your machine.
Right.
Okay. So, I mean, what is the guarantee? I mean, they can, theoretically blacklist our keys using Windows updates.
If you got things signed, you signed a contract with Microsoft, it dictates when they can do that, and frankly, if you're running a Linux box, it's not tool boot, then they don't have any mechanism. We have a mechanism, and we've agreed we'll deploy it. But we have a working relationship with these guys. I have a weekly phone call with them, and we talk to them, and we say, hey, do you have any security things coming up that we need to know about? And they're not hostile, they're really not.
And my take on it would be just to think, I find it useful to think about why that exists and why there's a genuine reason to have it, and then I think it's less likely to be nefarious. And there does need to be that mechanism, because the whole point is to verify that the boot chain is trustable. So if they sign it and then they find out later that, hey, there's actually a flaw in this and it can be exploited, they need a mechanism to withdraw trust from something. I mean, it's the heartbleed problem, right? You need to be able to say, oh shit, this isn't trustable anymore, we revoke that signature. It's a mechanism you need to have. So there are genuine reasons to have it, and those are why it exists. It doesn't exist for Microsoft to suddenly pull the rug out from under us 4 years down the road. And apart from what Peter said, the contractual agreement, there's also the less nice thing, which is, we always have this kind of hammer hanging over Microsoft, which is, if they get too evil and they start doing things that are obviously just ridiculous anti-competitive stuff, you know, we can go back to the Department of Justice and start making a noise, right?
And the hardware vendors, I mean, we sat in a big room, me and Matthew sat in a big room with them, with some bosses from Red Hat as well. And when we had this discussion, and the hardware vendors basically said, yeah, if you guys start dicking around with this, it's not going to fly. And we're going to start saying, okay, well, we're not going to ship it after all.
Yeah. Okay. I just wanted to bring up, because I just realized I didn't show it. I'll make sure this slide deck is accessible from whatever Flock gives to show slides. Otherwise, there are links to it on my blog. And if I just go back into presentation mode and go to the end, there is a resources page which links to useful stuff. Yeah, references. So if you grab the slide deck, there are some links there to sort of useful stuff which goes into a lot more detail and explains things that I forgot or couldn't get to in the time. And I'm always available to answer questions. Peter is sometimes available to answer questions if he's not too busy and or pissed off with something else at the time. Matthew Garrett's very good about answering questions and stuff. I can generally help you with the high-level usery things. If you need really deep technical details about Secure Boot, refer to Peter or Matt Garrett, or I mean Rod knows stuff about it as well. The Rod's Books link is a guy who doesn't have anything to do with Red Hat or Fedora, but knows quite a lot about UEFI and is a fairly reliable resource, I'd say.
And he types a lot. So.
He does, yeah. He's very verbose, yeah. He's got whole reams of stuff on his website, most of which is more or less accurate and useful, yeah. Yeah, so that's my talk, though. Thank you guys very much for coming along. I hope it's useful.